For those of you that have never heard of JWTs before, it stands for JSON Web Tokens, and they are, as it says here, an open industry standard method for representing claims securely between two parties. Or, in other words, it's a way to securely send JSON objects from one place to another. And JWTs can be very complicated. I'm going to be running you through a little bit about JWTs, kind of just all you need to know. I'm not going to be talking about absolutely everything because I'll be here for hours. But after I've done that, I'm going to be showing you how to encode and decode them in Python. A good place to start with JWTs is jwt.io. This website provides a nice little kind of representation down here of what a JWT is. So this is just a JWT string and what exactly the JWT contains. So there are 3 sections in a JWT, all of which are base64 encoded and combined into a single string separated by dots. So you can see a dot here and a dot here. This first section contains the headers. So this type is, oh bloody hell. Oh yeah, this website's a bit weird sometimes. But this type parameter is optional. The only one you absolutely need is this alg parameter, and this controls the algorithm used to sign and encrypt the token. And there are plenty to choose from, so you can actually choose from a list up here. So you have all these down here. HS256 seems to be used quite a lot. However, Google, of course being Google, uses RS256, and my experience of using JWTs comes from Google, and as such I'm going to be using this. The only thing that changes is the actual verification signature itself. The rest of the JWT is all the same, and as far as I can tell, encoding and decoding is a relatively similar process, or at the very least the libraries I'm using will be able to handle those other algorithms. But this is just what I know, so this is what I'm going to be teaching you about. If you're planning to use Google's OpenID Connect, then RS256 is the one you'll need to know. And RS256 seems to be somewhat left out in videos and Stack Overflow answers especially. So it's nice to give it a bit of a light and hopefully help out other people who are struggling with RS256 like I was not too long ago. The second part in purple is the payloads. This is the actual JSON data that you want to send. In this particular JWT, we've stored the sub, the name, admin, and IAT. You can store whatever you want in a JWT. There are absolutely no restrictions whatsoever. However, there are a few rules if you want to use them for certain things. So if you want to use them in OpenID Connect, for example, there are certain things. And there's a specific keyword, or there's a specific key, I guess, that JWTs look for, or JWT libraries tend to look for, to check whether a key has expired. There's a specific key that you need to provide for that, as per the standard. But I'll talk about that a little bit more near the end of the video. And then this blue bit down here, we have the verification signature. So for RS256, it is an RSA SHA-256, and then we have, your base 64 URL encode, public key and private key. There are 2 other things that we need to at least be aware of before we move on. The first is a JWS, which is a JSON Web Signature, which is used to kind of sign and verify the token. We don't need to know a huge amount about that because the libraries I'm going to be showing you take care of that for us. But just in case you run into an error regarding JWSs, then you know roughly what's going wrong. The second thing we need to know is JWK, and I'm going to be talking about that now because we need to encode a JWT, or we're going to encode a JWT. So if you come over to our code editor, we have a script ready for us. And we will want to do, when my terminal decides to load, there we go. We want to do pip install JWCrypto and JWT. So JWCrypto is a library that's good for encoding JWTs. We're not going to be doing the full encode process with it, but it has utilities in place to help us generate JWKs. And that's what we're going to be using it for. We're going to be doing all our encoding and decoding with the JWT library. A lot of people, if people know about this already, they might be thinking, why aren't you using PyJWT? The answer is I don't like it. I don't like how it works. I can't figure it out for the life of me. I spent ages. The documentation is rubbish. This library is just much easier to use because it supports JWKs out of the box, which is what I wanted for what I was doing at the time. So as you can see, we installed JWT, where is it? JW Crypto 1.2.14, I think. No, that's not it. That's deprecate. JW Crypto 1.5 and JWT 1.3.1. So what we're using in this video. So the first thing we need to do is need to specify all our imports. So we're going to do from jwcrypto.jwk import JWK, and from JWT import, I'm going all over the place, JWT and JWK from dict. And then we're going to have, that doesn't need to be double spaced, we're going to have a run guard, so we're going to have if name equals main. And then we're going to specify our data that we want to encode. So I'm just going to use the data that was in the example on jwt.io. So we have our sub, our name, our admin, and our IAT. And we're just going to have that as a dictionary. You can load that in from a file, or you can, take that from a request, or, anything you want really. And then we're going to generate a public key and a private key. It'd probably be better actually if we did private key and public key in that order. I suppose it's just a matter of preference. And we're going to create a function called generate keys. And we're going to generate that now. Or we're going to create that now. We're not going to generate it. So we have generate keys. It's not going to take any arguments at all. And then we're going to set our JWK object equals jwk.generate, and then we need to provide a few parameters. So I'm actually going to put each on a new line just so it's a bit easier to read. So we have our key type is RSA. If you're using HS256, and I think you'd put HS or HSA there, maybe. I'm actually not 100% sure. If your size equals 2048, alg equals RS256. If you were using HS256, you would put HS256 in there. We're going to supply our use, which is a signing key. And then we're going to supply our key ID, which can be anything you want, so long as it's a number. And we're just going to supply this as 420 because we're elite on this channel. And actually, I'm not going to bother having it on multiple lines. It all fits on the screen at once, so it's fine. And then we're going to return two things out of this function. So we're going to return. No, I forgot the word then for a second. We're going to return jwk.export private as dict equals true. jwk.export public as dict equals true. These by default export as a JSON string. However, for what we're doing, we actually want it as a dictionary, so we pass this as dict equals true. You could also use json.loads if you wanted to. We're not going to. So if we print private key, and then I guess we'll just do some really horrible debugging and do print public key, just so we can get an idea of what they look like. I might do a p print actually here. Yeah, I will. Just for the sake of making things a little bit easier to work out. If we run that now, if I could actually type, because my microphone obscures my keyboard, so it is a bit difficult sometimes. So we have these two things here. So we have our arg, d, dp, dq, e, kid, kt, y, n, and then all this, that, and the other. Our private key is a lot larger than our public key. And the public key, when you're using APIs, so if you use the Google API, the public key is the only one you're ever actually going to see. This is probably the most important one to actually know about. So the alg is obviously the algorithm. The n is the public key itself. I believe this to be the base64 encoded PEM key that we saw here. So that'd be this thing here. The reason I say I believe is because there are a number of caveats to this. If you look at the JWT docs, in some cryptography libraries import an extra octal, and then it gets really complicated. But thankfully, we don't need to deal with that. E is the exponent. This AQAB is base64 for I believe 65537. I got that slightly wrong, but it's. Would it be 65? It's either 65535 or 65537. I forget. You have the algorithm, of course, you have the key ID, and you have the key type, and then you have the use in here as well. Now we've generated our keys, we can use them to encode and decode our data. So we're going to start by encoding, and we're going to create a variable called token. Let's say encode data, and then we need to pass the private key, because the private key is used for encoding and the public key is used for decoding. Go up here, provide function called def encode, and then pass the data and then the key. And then before we go any further, we need to come up to the top and we need to do JWT equals JWT. So you can sort of think of this like a client. All the encoding and decoding logic is within an object. I don't really know why, because looking at the source code, it doesn't really look as though it needs to be an object. But it is. It's a design decision that was made, so we live with it. But we just put it on the top level, so it's available in all our functions without having to recreate it every single time, even though it probably doesn't really matter that much. So first, we need our JWK back, and we can do JWK from dict key. So this will be our private key. So this will take this dictionary here and turn it into, well, I suppose this is a JWK in and of itself, this dictionary format. But it just turns it into a, a Python representation that the library can use. And then we just need to do return JWT.encode our data with our JWK object using algorithm RS256, because we do need to supply that separately. And then we can also put in some optional headers. So as I said, the algorithm is the only header we need, but if you did want the type header, for example, you could do optional headers and then provide a dict. So it would be type JWT, like, that's a W, not an S, like that. And now you have an encoded JWT with all your data with RS256 encryption with our optional headers in place. And if we print that to the terminal now, we end up with a string that looks very much like this. And if we were to pass this, I think this is the end, including the G, come on. It's exactly 4 lines long in my terminal. That's quite impressive. If we paste that in here, then we can see that's, well, it's pretty much the same because all the data is the same. But we have our type and algorithm here, and then we have our private and public keys down here, and it all works just fine. That was my wallpaper. That's a very autumnal wallpaper I've got at the moment. Yeah. So now we have this token. This is what you could send out across the web to anyone, and because it's base64 encoded, you don't have to worry about any encoding problems, because everything can do with base64. And then you just need to have your decoder on the other side, or the client side, or potentially even the server side if you're sending something to a server. And that's what we're going to do now. So we can get rid of this line here. I'm going to scroll down a little bit. And then we're going to have our payload equals decode. And then we're going to be decoding our token using our public key. And this is a very similar function. We take the token and then we take the key. I still can't type. And then we provide, or we create a JWK again, JWK from dict key. And this is now taking, we'll see if it's even still on here, it is. So this is now taking the public JWK and using that to decode it. And then we can do a return of JWT.decode token JWK. So decoding something is a lot simpler than encoding it. And if we were to print payload, we will see that we get the payload back as we got it. And we can confirm that for sure by checking that our payload equals data. And it does. We have encoded and decoded successfully a JSON object. So I did want to talk about claims before I finish off this video. I've spent maybe like 10 or 15 minutes trying to find this web page that I found when I was researching this video, and I cannot find it for the life of me. If I do find it, I'll put it in the description. But I wanted to talk about claims and certain specific rules that you should follow when it comes to JWTs. So each of these keys, I've been referring to them as keys throughout this video. They're actually called claims in JWT. So the sub claim or the subject claim the name claim, the admin claim, and the IAT claim. So some of these are used in certain situations, some of them aren't. So the admin is an example of just one that JWT.io has included in there. That's completely custom, that's not normally there. The subject and, well, I think optionally the name are used in OpenID Connect ID tokens, and an IAT is also used in there as well. Name it can be used in user tokens or IAT tokens. But this gives a little bit of an idea. So you can see the sub claim, for example, claim identifies the principal that is the subject of the JWT, which is basically just a long way of saying it's a unique ID for the JWT. Audience claim, this expiration claim is the one that I wanted to bring a special attention to. The EXP expiration time claim identifies the expiration time on or after which the JWT must not be accepted for processing, and it is specifically EXP. This is what I was saying about with different rules. So if I were to have, say, like EXP is 100 here, and then we try and run the same thing again, we'll actually get an error when trying to decode the JWT, saying that the JWT has expired, because JWT actually checks this expiration for us and will reject it if the expiration has expired. In Google's case, this, and it might be an OpenID Connect specification, I don't know, but expiration is normally whatever the IAT is plus 3600. So this IAT is the Unix timestamp. I can't remember if it's seconds or milliseconds, but it's essentially the Unix time in which the JWT was created. The EXP is always 1 hour after that time. At least one's created to specification. Obviously, custom ones you could put, whatever expiration you want on it. The idea is that you don't use JWTs after they've expired, because it's more secure that way. The less time you have to send it around places, the less times it would be sent around places, and so the less opportunities for a hacker or a bad actor to, ever actually decode it. So that's the usefulness of an EXP. Obviously, everything is optional, whatever, you can put whatever in there. But that's a general idea of JWTs and a little bit of an idea of what I was doing in my spare time last week, trying to do JWT stuff for analytics, because I've been wanting to learn about them for some time. And now I've been able to teach all of you as well. If you like this video, make sure to leave a like to let me know, and consider subscribing if you want to see more videos like this. If you have any questions or ideas on what I should do in the future, leave them in the comments below. I read every single one, so your feedback is greatly appreciated. If you want to support this channel monetarily, you can do so either by becoming a member or a patron, £1 a month on either, and you can be on this screen like these people. And I'll see you in the next video where we talk about the new itertools.batched function. So I'll see you for that.